Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 217. Minimize deviation in array. So this was a tricky problem. I'm gonna go over this and then we'll do some minor quick code reviews and then you can watch me solve it live during the contest. So hit the like button and subscribe on Drum and Discord. And the way that I like to explain these problems is not just the solution, but the way that I thought about it during the contest, so that you see my thought process. You could fast forward in 2x or watch it in 2x if you feel that that's a little bit too slow. But anyway, so we have two operations, which is that one is given an even number, we could divide it by 2. Given an odd number, we could multiply by 2. But the key thing to know for this problem is that if this is an odd number, you can multiply by 2, obviously, as we said. But you can only do it once, right? Because once you do it, once you have an odd number and you multiply by 2, it becomes an even number. So you cannot do this again. You have to be divided by 2. Or you can only divide it by 2. So noticing that, I would try, the way that I was trying to do is, actually I misread this during the contest. I read it the other way. For some reason I just misread it. But from that, you would try to find an invariant, which is something that doesn't change as we loop through the array. So the first thing that I do for this problem, and I like to go with code, maybe visualization is a little bit tricky, let me know. But basically, for this problem, I took the invariant is that, or one of the things that we notice is that, as we said, because we can only do odd once, let's get it into a state in which we can keep on, where everything is the same and every number in the array is even, right? So that's basically my first idea. So for every number that is odd in the array, we make it an even number. We sort it, though. You can actually probably don't need to sort like this, but yeah, our best answer right now is just the biggest number minus the smallest number. And then the invariant is trying to figure out, let's say we have the biggest number that let's say we start the smallest number, right, in this new array. Our smallest number, once we get past the smallest number and we cannot go any longer, right? Because if we take the smallest number and we divide it by 2, and we go under the smallest number, yeah, because once we go under the smallest number, then we don't need it anymore. And then after that, it just becomes a heap problem of, okay, let's say you have a list of even numbers, right? So let's say you have this array. So we made it even, so, and sorted it. So let's sort it first: 1, 3, 4, 5, 20, and then we make them even. So 2, 6, 4, 10, 20. So okay, let's move to 4 here, right? So let's say we have an array of even numbers, which is how I thought about this during the contest. Well, the thing is that we, because we can only make the number smaller now because every number is even, we're always going to want to take in a greedy kind of way, we want to take the biggest number and make it half, right? So in this case, we take the biggest number, we make it half. We take the biggest number, we make it half, and and then now this is not the biggest number anymore. We take the biggest number, make it half, and so forth. So that's basically the idea behind this. And also, once we see an odd number, we know that this is the biggest odd number, so we're gonna stop there. So okay, so as we were doing the thing, the thing that we want to check, of course, is that, okay, we have the biggest number and then we have the smallest number, right? So that is what this problem is trying to find. That's the deviation of the problem, or the array. So every time when we take the biggest number, it could. So two things can happen, right? One is that it's still the biggest number, which nothing happens because you put it back in the array. It's the biggest element, and then we check it again anyway later, right? But if it is the smallest number, let's say for whatever reason, this is 6 and 6, and well, now we have a newest smallest number we put in the front. So now we just have to keep track of that. That if we divide it by 2 and it is the newest smallest number, then we use it to keep to do the calculations on later on. Otherwise, for every iteration, we know what the previous smallest number is, and it's going to be the current smallest number unless you divide it by 2 and it becomes smaller. So now we can just calculate, okay, now the range of this array is just 8 because it's just 10 minus 2, right? And then now this becomes a 5. So since it is not smaller than 2, we know that it's just going to be inside somewhere. So that's basically the idea. And using a max heap, that's how we're going to keep on popping off the top and so forth. And then the other thing is, well, why is it that when we get an odd number, we can stop? Well, we can get when we get an odd number, we can't do any operation on it, right? So that means that even if we go into the middle, let's say this 4, and we make it, we do operation on it, it doesn't change the answer, at least not for the better, because we could change this 2 to a 1, but that only makes the answer worse. So in a greedy way, after that, you're able to terminate. So those are basically the observations that I needed for this problem, and that's pretty much it. That's the implementation, is that while we have a heap element, and it should keep on having heap elements, and this is a max heap, so this is why I've changed them to negative numbers, because in Python, heap is a min heap, so I just did negative numbers to make it a max heap. So yeah, once this new number is smaller than the new small, then we break. I think this is actually unnecessary, but otherwise, again, this is the range. Now the current now is the biggest element in the heap, which is the biggest element in the array. So you do that from the largest element and the smallest element. We pop the heap, and if it's an odd number, we're done after we calculate the range. Otherwise, we update the smallest number to the new smallest number, and this is what I forgot to do during the contest, so I ate 5 minutes penalty and knocked myself out top 100, I guess. And then we push it back into the heap. That's pretty much it. And the invariant is such that everything in the array, we keep track of the new small is what I call it, but the smallest element in the heap, we keep track of that, and that's true. And then the biggest element is the top of the heap because it's a max heap, and that all the numbers inside between those two numbers, and that the biggest element will have to be an even number for us to go on. So that's pretty much it. This is actually, I found this problem, to be honest, easier than Q3. Q3 was kind of really tricky, but yeah, let's do a quick code review to see if people did it in any funky way. Oh yeah, I forgot to do an analysis. Did I do this? So what is the complexity for this problem? Well, it may look daunting, but because we're only divided by 2, or we get to, because we don't know how long this one loops, because for every element we put in the back, but it turns out that because we divide it by 2 every time, at worst, let's say the number is 2 to the 30th, at most that's going to take 30 operation to get it to an odd number. So that means that for each element or in the array, at most it's going to be 32 elements, or so it's going to be O of 32 times 10 to the 5th, which is fast enough. And in terms of space, it's just O of n, which is the input. So yeah, so O of n, O of n time, O of n space as a result. If you want to put the constant as log of the range, or the log of the u, where u is the size of the universe from 1 to 2 to the 32 or something like that. But yeah, let me know what you think. You could watch me solve it live during the contest. Let me see if I can... Okay, let me actually take a look. And it's 10 to the 5th. 4, 4, 5. Okay. Well. Was it so? Gives me something. Okay. It's 5 and 1. Okay. And now we want the biggest number. Yeah, it should be good because at most is 32 times each number. Maybe. Guess I don't need this bit. That. Okay, so that is a thing. Oh no, that's why I wanted the other thing. No, this is okay, maybe. wait, maybe you only do this if it's odd. So actually this is not true. Because that means you can only do this once. And now we have all even numbers. Now we want the smallest actually. There's a big number there. This is not even close. Wait, see. Oh, whoops. Kidding me? Oops. Oh my. Let's give it a go. Half an hour to go. Oof. It's one of those days. Can't even copy and paste into something. How do I get 0? So this is 6 and 10. No, I don't. Whoops. This isn't right. How did I not catch this? I meant to do this. Okay. That one. Ooh, okay. So I did. Hey everybody. Yeah, thanks for watching. Let me know what you think about this problem set. That was a very tough problem set. And this problem as well. So hit the like button, hit the subscribe button, join me in Discord. Let me know what you think. Let me know your questions, and I will see y'all next problem. Bye bye.